Hi, this is Isabella, and we are starting our last segment in pharmacy calculations, and we'll be working with dilutions and allegations. This is out of chapters 34 and 35 from your pharmacy calculations book. And you may recall last session we covered ratios and dosages based on weight and body surface area, infusion rates, and drip rates. So we're still going to be working with a little bit more complex problems, dilutions and allegations, but we'll get started in dilutions. And that is just referring to when you have a concentrated solution and you either add water to dilute, or maybe you'll add a different amount of mixture solution, the same drug, and you're trying to find out the new concentration. And allegations is referring to a method that you calculate the amount of a certain ingredient when you are mixing two other concentrated amounts of the same ingredient. So let's get started with dilutions. So on this slide titled Dilutions, dilution, it's when you have a less concentrated preparation of a medication from a more concentrated preparation. So you'll hear the term diluent, which is typically a liquid added to a more concentrated preparation to make a less concentrated preparation. And just as you recall with powder volume, we had diluent in powder volumes. That's when we would add water to the powder, and the water was referred to as the diluent. Such is the case with our dilution problems. And dilutions are covered extensively in chapter 34 of your calculations book. Now, calculations involving dilutions, we will have to calculate the final percent concentration or the ratio strength after two solutions have been mixed. Or we can be asked to calculate the amount of diluent that is needed to make a certain percent concentration. So let's take a look at the next slide. When we're asked to calculate the final percent concentration when two different percent solutions of the same drug have been added together, the first step we'll have to do is find out the total drug that's present. And we can do that by taking the percent that the solution is with the percent number on top over 100, because remember the definition of a percent. Then we multiply it by the amount of solution that's present in milliliters, and that gives us the amount of drug present in grams. Now you will do this for each amount of solution that's present. I had mentioned in the beginning that this is when you are adding two different concentrated solutions together. So you would have to find the total drug present in each amount of concentrated solution. The second step, we have to divide the total drug present by the total solution present and then multiply it by 100. That's to get us back to a percent strength. Now when it says the total drug present, you're going to have to add the two answers that you first calculated, because remember you have two different concentrated solutions. You find the total drug for each solution and then you add those two together. Then for the total solution in milliliters present, you would add each volume together as well, and you have to make sure that you're in milliliters. Sometimes they'll give it to you in liters or ounces. You have to make sure that you are in milliliters. Now, a time that you will not have to add them together, if it tells you that your solution has been diluted to such and such amount, then you know you're working with one volume. But when we're adding two volumes together, you're not only going to add the total drug that you calculate for each solution, but also the total volume for each solution. So again, that last step, total drug in grams over total solution in mLs multiplied by 100, gives us the new percent strength. So let's move on. We have an example. If 150 milliliters of a 12% solution is diluted to 225 mils, what is the percent strength of the new solution? Notice a few things there. One, we're being asked for the percent strength of the new solution. And secondly, you notice the word dilute. So we're not going to be adding volumes. We'll just be working with the final 225 milliliters. So the first step would be to calculate the total drug present. How do we do that? We take the percent that we're working with, which is 12%, and 150 mils. So it's 12 grams over 100, because that's the definition of a percent. Then we multiply it by the 150, because that's the volume we have present. So we end up with 18 grams, the total drug present. Second step, we want to calculate the new percent strength. And to do that, we'll take the total drug over the total volume, which is 18 grams over 225 milliliters. And then we multiply that by 100 because we want it to calculate the new percent strength, which is so many grams out of 100. So when you take 18 divided by 225, multiply by 100, we get 8 grams or 8%. Now, one thing I would just caution you on, be careful to use the correct amounts of volume. In this question, we were diluting. Some questions will ask if you have this much added to this much, then you have to add those volumes so that you have the accurate total volume. So why don't we take a look at a video illustration of calculating the new percent strength after diluting. Now we have an illustration that is going to run through how we work with finding a new percentage when we're diluting or we're mixing different concentrations of drug solutions. So these are all found in your pharmacy calculations book. Dilutions is in chapter 34. So we'll be calculating a new percent after we dilute or after we're mixing or combining different concentrations solutions. So we have 300 mLs of a 20% solution of a drug and 400 mLs of a 5% solution of the same drug. We're going to mix them together and we're asked what is the percentage strength of the final solution. So I want us to take a look at each ingredient at a time. So we're going to focus on this one first. And I find it helpful to kind of circle what volume is tied to what percent. This is helpful because the first step that we must calculate is what is our total drug. We have to know the total drug present. Once we have found the total drug, then we can look at the total volume, because we'll end up dividing those two, the total drug by the total volume, and then multiplying by 100. So because we have two different ingredients, or I should say two different volumes of different percentages as well, we have to first find the total drug in each one. So let's look at this. 300 mils, it's 20%. In order to find the total drug, we're obviously going to have grams on top because we're looking to find out the total drug. So remember that what this 20% means is really there's 20 grams of drug present in 100 mils of drug solution. But we don't have 100 mils, we actually have 300 mils. So we're going to multiply this by 300 mLs to calculate the total drug present in that portion of solution. So 20 divided by 100 times 300, we get 60. So 60 grams is present in that one. Now we're going to focus on the 400 mils, that's 5%. So that, same thing, we're going to do the same process. We need to know how much drug is contributed by that portion. So again, we'll have 5 grams over the 100, because that's simply from the 5%. This is a definition of percent. 5 grams for every 100 mils of drug solution. But we don't have 100 mils, we have 400. So we're going to multiply that out by 400 mLs. 5 divided by 100 times 400, you can easily see that that's 20 grams. So what we have here is the total drug that we have, this 60 plus this 20, we have 80 grams of drug total. And the volume, all right, total drug. The volume that we have here is 300 plus the 400, so we actually have 700 mils total here. So if I go back to this, I know that I'm going to take 80 grams over 700, which is my total volume, and I'm going to multiply this by 100 to get the final percent strength of the two combined volumes together. So 80 divided by 700 and then multiplied by 100, we get 11.43. And that is, it can be grams or percent. That is the final answer. So just remember, it's a two-step solving. First, finding the total drug. It's helpful to circle each ingredient so you don't mix that up with another volume. Circle the volume with the corresponding percentage. Find the total drug. Then make sure you find the total volume. In this case, we're adding. See, we have 300 mils and 400 mils. We mix them together. This is adding. Sometimes you'll see the language diluting. If you're diluting, then you would just look at the final volume. You don't have to add. But in this case, it says we mix them together, so this is adding. Then we divide those two out. We multiply by 100, and we end with our final percentage. So this is one example for our dilution chapter. So now we're still looking at dilutions, but now let's look at the types of problems that will ask you to find the diluent, or they might ask you how much water should be added to this to get this. So some questions will also ask you the beginning concentration, or they'll ask you for the beginning volume of a solution, or the ending percent. But let's take a look at specifically if a question asks you how much water should be added. So I'll move to the next slide on how to find the diluent. First, we're going to calculate the total drug present in the beginning solution. So it might be helpful to isolate that beginning solution if you have to circle it, or do what you have to do so that you can single out on that starting amount of solution. And you'll take the number of the percent over 100, and then you'll multiply it by the volume that's present there, or the volume of the beginning solution, same thing. And that gives you the total drug. Then you want to calculate the final volume. So you'll take the percentage, which, it means so many grams out of 100 mils. So since we're trying to calculate the final volume, we'll have milliliters on top. And since it's out of 100, we'll have 100 on top. We'll put down the percent on the bottom, and then we'll multiply that by the total drug in grams. So the answer that we figured out from step 1. That gives us the final volume of the new solution. So just remember, we're beginning with milliliters on top because that's what we're solving for. And it's 100 because we're dealing with that percent, so many grams out of 100. Now the last step, step 3, we're just going to take the difference of the final volume and the amount of solution that was added. That will give you the amount of diluent that you need. And just so you know, the amount of volume that was added, the question is going to give you that information. So it's what we calculated from the final volume and taking the difference of what was being added, which is in the question. So I know it might seem more simple, or it might even be confusing to hear these steps. Why don't we take a look at a video illustration on how to find the diluent. Now this is an illustration that we're going to walk through that it's taken from the Dilutions chapter, but it's kind of a combination of powder volume, dilution, maybe even allegations if you think about it. But let's take a look at this more in depth. We have on hand 50 mils of an 80% dextrose solution. We need to make as much of 35% dextrose solution as possible. So we need to find out how much water are we going to add to the 50 mils of the dextrose 80% solution. So anytime you see like water or some other ingredient that is not contributing drug, that's actually a 0% solution, or it could be referred to as the diluent. If you think of like how when we were doing powder volume. So really it's what we're adding to dilute an actual drug solution. So what we're going to do here is I'm going to take the powder volume approach, and if you recall from those types of problems, the first thing that we did was calculate the total drug present. And in order to do that, we're going to zone in on the 50 mils of 80% dextrose. So if I'm trying to find out the total drug there, I'm going to have 80 grams over 100 mLs, because that's the definition of 80%. But what I have on hand is 50 mLs. So I see that my total drug is just half of the 40 or 80, so it's 40 grams of total drug. Now I'm going to calculate what is the final volume or the total volume that I have present here. Well, I'm going to use this here because this is going to be my end product. So I'm going to have 100 mils over 35 grams, but what I have is 40 grams. So you see the grams canceling out, I'll be left in mils. 100 divided by 35 and then multiplied by 40 gives us 114.28. You can leave it at 114. So this is what the total volume will be. They're telling me that I'm adding water to 50 mils of 80% dextrose. So if this is my total volume, then if I subtract 50 mLs, which is coming from that 80% dextrose, then the difference here will be what I'm adding in water. So we have, you can round it to 64.29, but we'll just say 64 mils is what we're going to add from the water. So this was a slightly different approach, and yes, it can either be dilutions because you see we're adding water to this, but you can also use the powder volume method because we know that there are two components that equal that total final volume. One is coming from this portion and the other is coming from the water. So we took this step of calculating the total drug, which we focused on this 50 mils of 80%. We know we have 40 grams of drug present. Then we took the final volume by using our end product of 35%, which 100 mils over 35 grams will lead us to the volume because we have milliliters on top. Then we multiply it by the total drug that we have, 40 grams, and then we get 114 mLs. So 114 mLs is the final volume, and when we take away the 50 mils, we get 64 left over. So this is the water, and the 50 mils is the 80% what we're adding. So this is yet another example of our dilution type problem. Okay, so now we're on the last concept for the last phase of pharmacy calculations, and we'll be ending with allegations. Allegation is a type of calculation that will help us determine how much of two concentrations of the same ingredient that are needed to prepare a third concentration of that same drug between the two. Now, you'll hear the term parts, which refers to the relative amount of each ingredient to be mixed. It's even more important when the problem doesn't give you the final volume or weight of what's being prepared. And allegations is found in your calculations book in chapter 35. And this is used in cases when a particular percent is being ordered, but it's not available. So the tech can prepare it by mixing together a stronger percentage solution and a weaker percentage solution in the correct proportions or parts to achieve what was ordered. Let's say you have an order for 20% solution of something, but you only have on hand a 50% and a 10%. So how much of each would you use to achieve that 20%? Remember too that parts are like a ratio, so it's a 1-to-2 ratio or some other example like that. But if you're given the amount of one ingredient, then you can calculate what the other ingredient would be if you're not given the final volume. But in most cases, you know what the final volume would be. So let's move into how we set these problems up. So the next slide is the allegation layout. So it looks similar to a tic-tac-toe box, and you would fill in that box with the higher percentage solution that you're using in the top left-hand corner and the lower percentage solution in the bottom left-hand corner. So you're just going to put the whole numbers there. You don't have to alter it. You don't have to change it in any way. Just put the numbers in that designated spot. Then you will put what's prescribed or the desired percent in the middle. I call that the bullseye. That should be helpful to remember because it's what you are intending to make. Now the next slide is just more of the layout and the steps we take to solve. So it's diagonal subtraction is what it is. So you're going to take the higher percentage and subtract the desired percentage from it. That'll give you the number of parts of the lower percent that's needed. Likewise, with the lower percent, you take the desired and subtract it from the lower percentage, and it giving you a number of parts of the higher percent that's needed. So notice how even though you're going diagonally across, up or down, that end result or that end answer is reflecting what you see to the left of it, to the far left of it. And keep in mind too that you don't want to end up with a negative number. So sometimes when you take the higher strength minus the desired, you could get a negative number. In a case like that, then you would take the desired minus the higher strength. So just remember, you'd never want to get a negative number. So now we have the parts of each ingredient that we want. What you need to do then is you're going to take both of those parts and add them together. And then for each part, you'll work with one at a time. So for each part, you would take that number of parts divided by the total number of parts, then multiply it by the total mixture that you're making. It has to be either in grams or milliliters. So remember, if you're given the total mixture in, let's say, liters, you'll want to convert that to milliliters. So now let's take a look at an actual practice problem. In this example, we're to prepare 2,000 milliliters of a 29% solution using a 27% solution and a 31% solution. So how much of each will we use? So we can automatically draw out a tic-tac-toe box and fill it in so that we have 31 in the top left-hand corner, because it's the higher percent, and 27 in the bottom left-hand corner. Now, your calculation book states higher percent in the top left-hand corner and lower percent in the bottom left-hand corner. And I believe your purple book has it the reverse. It doesn't really matter which one you choose to do, as long as you stay consistent with that end result, or the end answer is going to correspond to what you see to the far left. Don't get them confused, like the top right hand being associated with the bottom left hand. It's got to go directly across to the right. So we'll do it this way because this is how I've been explaining it. But so high percent on the top left hand corner, lower percent on the bottom left hand corner, and 29%, which is what we're making, is going to go directly into center. So we're going to subtract diagonally. So you see the 29 is going to be on the top right hand minus 27, and that gives us 2. And on the bottom right, you see 31 minus 29 gives us 2 also. So when we add those two together, we have a total of 4 parts. It's 2 parts for each ingredient. Then we're going to divide by the total parts, then multiply by the total amount of solution we're making, which is 2,000 milliliters. And when you punch that out, for this particular problem, it just happens to be the same for each ingredient, but you can't always go that route or think it's going to work out that way. 2 divided by 4 multiplied by 2,000, which just basically means half of 2,000, we get 1,000 milliliters. So we will use 1,000 milliliters of the 27% solution as well as the 31% solution. So why don't we take a look at a video that's showing this again. I'll choose a little bit more complicated one, and I'll also do another example in which the problem does not give us the final solution or the final amount of mixture that we'll be using. So you can see them played out in both ways. So let's take a look, and we'll end our session with that. You've gone through all of the calculation sessions, so that's great. If you need to go back and review, that's the nice thing about the videos. So I would encourage you to take advantage of the videos. That should be very helpful, or just email me if you need more assistance. Thank you. Now this is an illustration that we're going to walk through that it's taken from the Dilutions chapter, but it's kind of a combination of powder volume, dilution, maybe even allegations if you think about it. But let's take a look at this more in depth. We have on hand 50 mils of an 80% dextrose solution. We need to make as much of 35% dextrose solution as possible. So we need to find out how much water are we going to add to the 50 mils of the dextrose 80% solution. So anytime you see like water or some other ingredient that is not contributing drug, that's actually a 0% solution, or it could be referred to as the diluent, if you think of like how when we were doing powder volume. So really, it's what we're adding to dilute an actual drug solution. So what we're going to do here is I'm going to take the powder volume approach. And if you recall from those types of problems, the first thing that we did was calculate the total drug present. And in order to do that, we're going to zone in on the 50 mils of 80% dextrose. So if I'm trying to find out the total drug there, I'm going to have 80 grams over 100 mLs because that's the definition of 80%. But what I have on hand is 50 mLs. So I see that my total drug is just half of the 40 or 80. So it's 40 grams of total drug. Now I'm going to calculate what is the final volume or the total volume that I have present here. Well, I'm going to use this here because this is going to be my end product. So I'm going to have 100 mils over 35 grams, but what I have is 40 grams. So you see the grams canceling out, I'll be left in mils. 100 divided by 35 and then multiplied by 40 gives us 114.28. You can leave it at 114. So this is what the total volume will be. They're telling me that I'm adding water to 50 mils of 80% dextrose. So if this is my total volume, then if I subtract 50 mLs, which is coming from that 80% dextrose, then the difference here will be what I'm adding in water. So we have, you can round it to 64.29, but we'll just say 64 mils is what we're going to add from the water. So this was a slightly different approach, and yes, it can either be dilutions because you see we're adding water to this, but you can also use the powder volume method because we know that there are two components that equal that total final volume. One is coming from this portion and the other is coming from the water. So we took this step of calculating the total drug, which we focused on this 50 mils of 80%. We know we have 40 grams of drug present. Then we took the final volume by using our end product of 35%, which 100 mils over 35 grams will lead us to the volume because we have milliliters on top. Then we multiply it by the total drug that we have, 40 grams, and then we get 114 mLs. So 114 mLs is the final volume, and when we take away the 50 mils, we get 64 left over. So this is the water, and the 50 mils is the 80% what we're adding. So this is yet another example of our dilution type problem. Hello, now we're back and we're still looking towards the end chapters here, and this is an illustration that we're going to see what's called an allegation problem, and this is, I like to refer to as the tic-tac-toe box method, when we are taking two different percents and making an entirely third different percent of the same drug solution. So here we have on hand a 10% and a 3% of this ammoniated mercury ointment. We need to prepare 450 grams of a 5% ointment. So we want to know how many grams of each of both the 10% and the 3% will we need to add. So in this method, you can set it up. Like I said, I refer to it as this tic-tac-toe box. And we're going to put in the middle our bullseye, or what we're making, and that's this 5%. Off to the left side on the top, we're going to put our higher percent ingredient, which is 10, and on the bottom, we're going to put our lower percent ingredient. So this is the first setup. On the left, we have the ingredients that we're using, the percentages. In the middle, we have the percent that we're trying to achieve or make. Now we're going to go kind of diagonal, and we're going to subtract. So the next thing we do is subtract diagonally. So here, I'm going to have 5 minus 3. And the reason that I do that is because I never want to have a negative number. So I wouldn't do 3 minus 5. That would give me a negative number. I'm going to do 5 minus 3. I get 2. Same thing on this way. We're going to go diagonally across, and we're going to subtract 5 from 10. So now we have parts. I have 2 parts and 5 parts. When we get done in the end, the final result that we get here is actually going to be attributed to that ingredient. So we're just going to kind of throw that out there so we kind of know here. But I need to know what the total parts is that I have. If I have 5 plus 2, I have 7 total parts. Now I'm going to look at each ingredient individually. So I'll look at the first one. I have 2. I'm going to divide it by the total number of parts, and then I'm going to multiply it by the total quantity that I'm making in grams. I'm making 450 grams. Now see, this is important too. They already give it to us in grams, so I don't have to worry about converting that. In some cases, they might give it to you in a different unit, so be sure that you are in grams or milliliters if it was a solution. So 2 divided by 7 and then multiplied by 450, I get 128.57, and I'm just going to round that off to 129. So remember, I said this end result is referring to this ingredient. So I need 129 grams of the 10% ingredient. Now we'll look at this individually. So 5 divided by the total parts, which is 7, and then multiplied by the total quantity that I'm making. So these numbers will stay the same. 5 divided by 7, then multiplied by 450, I get 321.4, and I'll just round that off to 321 grams. And this is referring to the 3%. So you can see in the end that you're going to have 2 answers here because you have 2 ingredients. So you have 2 answers, and together 129 and 321, they equal 450. So that is working out good because that's actually what I'm making. I'm making 450 grams of 5% ointment. So this is an example of a problem that we utilize allegations or the allegation method, and it's helpful to kind of pinpoint this method when you see 2 percentages adding together to make an entirely different percent, and that's an allegation type example.